So if you don't have a printout of these notes, you're probably going to want some paper to copy all this down. You're likely to need it when you try the practice, which is a Google form. Okay. So this is kind of summing up some of the stuff that we already know, but let's talk a little more about solutions, which we haven't so far. Quadratics, remember, are second degree polynomials. That just means they have an exponent of 2 on the variable. If you remember, a parent function is just the most basic quadratic. So standard form is ax squared plus bx plus c equals y, right? So if we think about up here, well, a is 1, b must be 0, and c must be 0, right? Second form that we've been looking at is vertex form. Vertex form, and it has this, remember, subtraction is kind of important here, and addition is important there, right? These are all important up here too. And vertex form obviously gives me the vertex. And then factored form, or intercept form, sometimes we'll see it maybe with plus n. If we have it as minus right here, then r sub 1 and r sub 2 are the roots, or the x-intercepts. And that brings me down to here. Why are those so important? Those are actually the solutions of a quadratic function. Now technically all the points along, the graph of that equation would satisfy the equation, so they're all technically solutions. But for quadratic functions, the solutions we call zeros, or roots, or x-intercepts, and that's because they answer when y is 0. What is x? So if you think briefly about the three, there's 3 types of solutions. Maybe if you think about how these would look when they were graphed. Okay. By the way, set notation. Remember we did that for a while. Just put it in braces. Well, the first possibility is pretty typical. We would have 2 solutions, and that's because the parabola would intersect the x-axis twice. This is where y is 0 and where y is 0, right? And so this could be an example of what that coordinate was, and this could be an example of the second place where it intersects the axes. So we could write it in set notation like this, or we could say plus or minus 3, right? Now, we could have one solution, and in that instance, it's because it only touches the x-axis once, and that's at the vertex, right? So we would just put it in braces like this. Yes, you could also say that it's negative 2, 0, for example. And of course, we could have no solution where the parabola is either above or below the x-axis. It never touches it. So you could put this inside your braces, or you could say it's the null or the empty set, or you could just say there's no solutions. And this might be a case where, let's say you were backbraining, you might say, well, it's not factorable. So we might find that there's no solution. Okay, so this, if you got it printed off, that probably saved you a lot of time. What I want you to do, though, is maybe pause the video and get yourself a piece of paper. We're going to flip this over and take some notes on the back side. And they're going to be about methods. So let's see if you can see this. I know my lighting's not too good. I waited till a little too late in the day to tape this. I'm sorry. I think I should have this. Okay. So we are going to start using these methods tomorrow. But first method we're going to look at is called the square root method. And I think I'll give you a little information on this one. And that's works when there's no b value. in your standard form of an equation. Okay. And then after that, we're going to talk about, it's very, very closely related. They're still kind of the same method. But the second method will be completing the square. So you can see why we've been spending some time maybe reviewing that. Remember when we complete the square, we put that function into vertex form. Method that we're going to look at after that, sorry about that, is factoring. So again, that's why we spent so much time reviewing factoring. Factoring is a method for finding the zeros. We're going to write something down right now for your notes. ZPB. I'll tell you what it stands for now, but we won't talk about it for a couple days, okay? Running out of space. There we go. All right. Fourth, quadratic formula, and some of you have seen it or heard it. This last one is usually where I start, and because we have remote learning now, we kind of had to give up some things, and this was one of them. So this was graphing. Really, this would be if you had a graphing calculator. You've probably done it where you go to calc and you find the zeros. So that's something you might want to keep in mind when you do the practice for this lesson. You'll want a graphing calculator, you want some scratch paper. Hopefully you've done all that practice with converting forms, because these methods are obviously contingent on the form that you're provided. Okay, good luck on the practice.